Welcome back to Intermediate Algebra. Today we have section 3.1, paired data. So we're going to look at a lot of things here quickly that have to do with graphs. Hopefully most of this section is a review, so you've seen it before, but we're going to just kind of buzz through a few things really quick. First off, let's graph an ordered pair. In this case, I have the ordered pair -3, +2. Remember, an ordered pair is an x and a y value. They give us directions to 1 point, not 2 points, just 1. So our point here is at -3, +2, right? The first number, the x number, goes left and right on the x-axis, so I went left to -3. Second number is our y-coordinate, so that's the y-axis, up and down. So I went left 3, up 2. There's our point. Probably know how to do that, hopefully. All right, so now let's talk about graphing a line. So I have the line y equals 2x minus 1. Now some of you are like, hey, that's in slope-intercept form. In which case, fantastic, you already know that. That's coming later in the chapter, so you'll see it there. But for those of you maybe who don't remember slope-intercept form, don't worry about it, we'll get it. For now, all I'm going to say is we just need 2 points that make this work. So what I did is I plugged in 0 for x, and then I plugged in 1 for x. I did those separately. So when I plugged in 0 for x, you can see 2 times 0 is just 0, and 0 minus 1 gives me the -1 for y. So I plugged in 0 and I found the -1 for y. And then I did the same thing with 1 for x. 2 times 1 is 2, 2 minus 1 is 1, so I get the ordered pair 1, 1. Once I have my 2 points, I make my 2 dots, just like we did back over here. And then I connect them with a line. Notice I put arrows on the end because these do go on forever. Please don't just connect the dots. If you just connect the dots, I'll take a point off because that's not a line, that's a line segment. Make it go all the way through. All right. So anyway, we can graph points, we can graph lines, and now we're going to look at a few other things. All right, next up, 2 other kinds of graphs that we want to at least be familiar with. The first is what's called a parabola. Parabolas usually come out of equations that look something like y is equal to x squared. Okay? So your basic parabola, if you set up a chart so you can get some ordered pairs, if you plug in 0 for x, 0 squared is 0, so you get 0 for y. If you plug in 1, 1 squared is 1, and if you plug in -1, be careful, when you square negative, you always get a positive. If you put in your calculator, the negative would have to be in parentheses before you square it. Anyway, we get 1 with that as well. And so you can see I made my graph. I have the point at the origin at 0, 0, at -1, 1, and at +1, 1. I have my 3 points. And a parabola is always a nice, smooth kind of U shape, as opposed to the absolute value we're going to see in just a second. So make sure that it's not pointy. Okay, parabolas are never pointy. They're nice and smooth, as opposed to the absolute value. Absolute value of x, y is equal to absolute value of x. Again, I plugged in some x values, and I got y values. The nice thing about absolute values, whatever goes in, it comes out, same thing, just positive. So 0, 0, when I plug in 1, I get 1. When I plug in -1, I get 1. Notice it's got the same set of ordered pairs so far, it won't for very long, that y equals x squared does. But it has a very different shape. Absolute value is always going to end up pointy. It's going to be V-shaped. Okay? So I get that nice V shape, and I really just want you to know what these 2 graphs look like because we'll do stuff with them from time to time. All right, so let's move on and let's talk about moving these graphs up and down. Okay, vertical shifts. A vertical shift happens if you add k or subtract k, where k is just any number you can think of. So adding k is going to move your graph up, and subtracting it will move it down. It's just as straightforward as that. If you add a number at the end of what you had, it's going to go up. If you subtract it, it goes down. And I think that kind of makes sense. Let's look at this example. I have the absolute y is equal to the absolute value of x minus 2. So you can see my dotted lines here. I had the original graph of y is equal to the absolute value of x. Okay, it goes through 0, 0. There's my -1, 1, and my +1, 1. You can go back just like 30 seconds in this video and see the table of values that would have gotten that. But now, since I have a -2, what that's going to do is it doesn't change any x values. So that's why my graph isn't moving left or right, but it's going to take everything and it's going to shift it down 2 units. So you can see I just took those 3 points that I had before, I just dropped them all down 2 units, and there's my new graph. And so it's a really much nicer way to go about making graphs. You don't necessarily have to make a table of values for everything. If you know what the basic graph looks like, turns out there's a lot we can do with them without actually having to resort to making tables of values. If you need to, make the tables, but sometimes it's really straightforward. You go, hey, that's just down 2 units, and you drop the whole thing down. All right, let's continue on. Okay, so the last thing I want to talk about here today in this video are intercepts, x-intercepts and y-intercepts. So an x-intercept is any point where a graph crosses the x-axis. Here's the key. For any x-intercept, think about a graph, okay? I don't have one on the board right now because I have this little teeny board and it just doesn't fit here. But think about a graph. If you have a point on the x-axis, the y-coordinate has to be 0. Okay, if you don't believe me, go and look at a graph and just kind of stare at it a little bit and notice that any ordered pair, any point on that x-axis, the y-coordinate has to be 0. And that's what we're going to take advantage of to find x-coordinates. X-intercepts, sorry. Anytime you want an x-intercept, you're always going to put in 0 for y. Y-intercepts are the exact opposite. Now we're on the y-axis. We're at a point where the graph crosses the y-axis. And for that, x always has to be 0. And so we can find these two things just by plugging in 0 for the other one. So case in point, I have this example, 3x minus 5y is equal to 15. Now I'm just going to go ahead and find the x-intercept. I'll leave you to find the y-intercept. Here's a hint, plug in 0 for x. All right, so I'm going to find the x-intercept. I plug in 0 for y. So you can see I have 3x minus 5 times 0 is equal to 15. I put 0 in for y. And then I kind of crossed out the 5 times 0. Go ahead and do it fully now so we can see that. It's gone because anything times 0 is just 0. So that part doesn't even matter. So all I'm left with is 3x is equal to 15. Divide both sides by 3. And I get the x is equal to 5. So the ordered pair where this is going to be a line where this crosses the x-axis has to be at 5, 0. So there you go. That's section 3.1. Hopefully a lot of that looked really familiar. And yeah, we're going to do some other fun stuff later in the chapter. So thanks.